I tend to do some things that involve audience participation, so let's all practice raising our hands to make sure that we can. You all have hands, I saw you. Excellent. Now, if you don't raise your hand for a question, we know you can raise your hand, so I can totally call you out on that. Before we start, I want to do a brief commercial that has started already. I've written 3 books for the Java 8 certification exam, and my co-author and I are updating them for Java 11. What's really cool is the Java 11 one just came out, and it's already on the top of the Oracle certification bestseller list, so there's a lot of pent-up demand. In fact, it was back-ordered on Amazon for a while, but a copy just made it to San Diego. Now we have a physical book that I can show off. So thank you, Greg, for bringing the physical book. Now you can have it back.
Yep, literally came today.
Yeah, and I got mine on Saturday, so I've only had mine for maybe 10 days now. Pretty fast to get across the country. It's a 2-part exam. We're working on the 2nd book. That one comes out in April. But, you know, it's cool. About this talk. I'm going to be presenting at Dev Nexus in Atlanta on Java Idioms in February. This is the first time I've ever presented this talk to actual human beings, so this is the world premiere of Jeanne's Java Idioms talk. I'm assuming that people are on Java 8. Let's check if that's true. Raise your hand if you're on Java 8 or higher. Oh, good. And raise your hand if you're on Java 11 or higher. Okay, perfect. That's what I was hoping the answer would be, and that is the profile of where people are at companies in New York City, but I didn't want to assume since we're on the other side of the country here. Also, because this is the first time I've ever given this talk in front of real live human beings, there's probably at least one error in it. So, if you see an error, raise your hand. If you correctly report an error, you get a piece of candy. There's also a couple of opportunities to win candy in talk number 2 for answering questions that are in the talk. So it behooves you to pay attention. Free candy. I don't charge $1 for it. To get started, we're going to talk about what an idiom is or isn't, and then we're going to look at some common idioms in the space of strings, file I/O, collections, and streams. This should help you develop things faster by having to type less and being able to write code that's more readable to others on your team, and hopefully teach them some better ways of doing it. It was inspired by a discussion I had with some teammates a good while ago, and then has gravitated over the years. They showed me, it was in JavaScript, it was this page-long thing of validation. My teammate comes over and says, "This doesn't work, can you help me?" Well, really long and complicated. Well, what's it supposed to do? They tell me, that's a 1-line regular expression. It's not even a complicated one. So we rewrite it in 1 line, it works. And then the person goes to me, "Can you help me debug the original?" No! Helping you debug goes on forever. But that got me thinking about the importance of teaching my teammates common idioms. By having seen the idiom before, all you need to do is apply it to your situation, not invent it every time you need to do something. That makes things faster. I felt bad throwing away their page-long work of art because I'm sure it took a long time to create, but it would have taken even more time to maintain. It was the right thing to do. So what's an idiom? First thing, an idiom is a recurring construct. It's something that happens often when you're writing code. For example, you need to go through an array looping by index. This is something as Java developers we all know how to do without thinking about, because it's a basic idiom. It has meaning. You can express what this is. We're looping through an array. And it's a common approach or a common way of doing things. There are many ways you could loop through an array. If you got a junior developer on your team who said, "I know, I'm going to loop through an array. For int x equal 1, x is less than or equal to length, x plus plus, and I'm going to reference it as x minus 1. Can you change that? Right, you're going to say something about it. Because while that approach isn't wrong, it is non-standard, and it's going to cause you and everyone else on your team problems forever. It's good to learn and use the idiom. That way, it's something that everyone can deal with. You get a new person from another company, they're like, "Well, what's with the way these people write for loops? This doesn't make any sense to me." Now, what's not an idiom? An idiom is not a design pattern. There are a lot of commonalities, though. A design pattern is also a reusable bit of code. It achieves a common purpose. It's usually a standard way of doing it, but it's higher level. It may be language agnostic. For example, the factory pattern, you can implement that in almost any language. I say almost because we've got some immutable languages where it doesn't make sense, but most languages. And they're things that people will recognize by common names. Think Martin Fowler's book for design patterns. An anti-pattern is also not an idiom. It's a common solution, if you can call it that, but it's wrong or bad. An idiom is something that you want to be doing. An anti-pattern is something you don't want to be doing. We're going to look at 4 examples and see if we can figure out what we think they are. So this is our first example of something. It's either an idiom, a design pattern, or an anti-pattern, or none of the above. I'm going to take a moment to let you read it, and then we're going to vote with our hands, because remember, I like to see people raise their hands. Observation 1, gray does not look good on the screen. Okay. Well, I've noted that. You all should have had time to read. So who thinks this is an idiom? Who thinks it's a design pattern? Who thinks it's an anti-pattern? Okay, and who thinks none of the above? Yeah, so I think it's a design pattern. I'm curious to hear from the anti-pattern people what's wrong with it.
It could get locked. You know when to release.
Okay. It was supposed to be a singleton, so it would never get released, but that's a good point. Did anyone see any other problems with this that voted anti-pattern?
I could be wrong, but don't some people think that singletons are bad design? Just
Okay.
so.
Bad pattern.
But I said it was
Yeah.
a pattern. I said it was a pattern.
No, but that's a good reason for why it could be an anti-pattern. I like that one. And it's definitely not an idiom. We all agree it's not an idiom. But I like those as reasons for why it could be an anti-pattern. On some level, these things are subjective. If you Google singleton, you'll see a bunch of things that are clearly wrong ways of doing it as well that are called patterns. But not an idiom. It's too high level to be an idiom. Okay. Now let's look at another example. The unreadable gray says count positive. And in particular, we're looking at the loop and the if statement part of this.
Anti-idiom choice.
I guess that would be an anti-pattern or other. You can vote twice. All right, who thinks it's an idiom? Design pattern? Anti-pattern? Other? All right. I'm going with this is an idiom. There is a bit of a gray area on this though, because for 2 reasons. The first is there's a whole algorithm on the screen, and an algorithm is clearly not an idiom. The second one is this was the pre-Java 8 way of doing it. You really should be using a stream by now. So you could argue that it's an anti-pattern because this is the long drawn out way of doing it. But the for loop part is an idiom, and I think that that shows the point of, okay, we all know how to write a for loop. Okay. Number 3. I hope this one is easier. The gray says do everything, and the comment says ignore. That sounds like it might have been a clue. All right, who thinks it's an idiom? No one, good. Who thinks it's a design pattern? Anti-pattern? Yay! Yes, this is an anti-pattern. It's got 2 problems. The first is it catches every exception under the sun. Don't do that. I can have do work, do anything I want, and this code will end without error. And the other is after this terrible thing has happened, I don't even log it. So this is like the perfect example of how not to write code. And then we've got example number 4. The gray says count positive again. This is a rewrite of the for loop one. Okay, what do we think? Idiom?
No.
Design pattern? Anti-pattern? Other? Yeah, this is another. It's code.
Yeah.
It works, I suppose. But it's a complicated way of doing this. The reason it's not an anti-pattern is you can't point to one thing that's wrong with it. Right? It's not like, oh, well, writing a while loop is evil. But there's better ways of doing it, so it doesn't really fit any of the categories. And that's okay. These aren't mutually exclusive categories or boxes things go in. But they're good vocabulary for talking to your teammates about how do we do things commonly in ways that are good and not ways that are bad. How do we communicate about what something is? Okay, next up we're going to start by looking at Jeanne's favorite idioms. In particular, we're going to start with strings. Okay, our first one is not an idiom before anyone gets too excited about it. You can tell because IntelliJ has a warning on this line. But it is intended to validate that a string has PalmTree in it, because we're here in San Diego and there's lots of palm trees, so you shouldn't be able to look out the window without seeing one. It does work. It checks if the word palm is anywhere in the string, and if it's not, it throws an exception. And technically speaking, there's nothing wrong with this. It will pass the unit test, it will pass an integration test, it does what it's supposed to. But it's a little harder to read than it needs to be, and IntelliJ is warning you about this fact. Using index of is tricky because you have to do it correctly, and a lot of the time there's better ways of doing it. So this isn't the best way of writing this code. You could use the contains method, which does the exact same thing, except it does it in a more readable way. Using a contains method in order to check for the presence of a substring is an idiom. It's a common way of solving a problem in Java. Good to know. It's also harder to screw up. Right, with my index of thing, well, what if I don't write less than or equal? What if I write less than or equal to 0 or greater than? Now I have to start thinking about, is it right? What does this do? As a team member who's reading this, if tree contains pair, palm is false. It's like, okay, I know what that does. That's good. Our next example, also not an idiom, although at least this one IntelliJ doesn't complain about, so we've made progress, is checking to see if a string only contains white space. So it's trimming the string, that's good, we care about white space. Then it's checking if the length is equal to 0. I see this one a lot when I'm working with developers because we're used to doing that. We're used to saying, okay, I'm thinking about the length, and I am. But it would be better to say is empty because that method exists and it expresses the intent that we're trying to share. We're writing our code for ourselves in the future, for our future teammates who may or may not be on the team yet. And writing it in a way that's going to be easier for them to read is better than writing it in a way that reflects what we were thinking at the time. This shows that knowing the APIs of Java is really useful, especially in the classes we're going through today. These APIs you use over and over and over, so they can make your code a lot more readable and a lot more powerful. Next up, we need to remove some sort of pattern from the beginning of a string. In this case, we're going to remove all the leading numbers because I like to. Now, this is the type of thing where we get to my JavaScript example from the beginning of, okay, well, what do we have to do in order to make that happen? I could write something that has a complicated loop in it to keep track of the characters and when I need to start and then I need everything from that place. And if I wanted to be really tricky about it, I could say, okay, you know what I'm going to do? I'm going to use that loop to figure out the index, and then I'm going to use substring to figure out what's left. That creates code that's buggy and hard to understand. But that often happens in the real world because people are afraid of regular expressions. I'm going to try to cure you of that a little. So the next time for a survey, who loves regular expressions? Yes, I'm not alone, I'm among friends. Who hates regular expressions? My co-author, Scott, hates regular expressions. We needed a regular expression written for something. He wrote a unit test for it and handed it to me. He's like, fill in the blank, please. But at least one of us likes it. It wasn't even a complicated one. What we're doing here is we're using a string API method, replace first. There's a replace first and a replace all. Both of them deal with regular expressions. I try to use replace first if I'm only replacing one thing because it better expresses the intent that there's one thing being replaced here and not every time it occurs. And then I have the most specific regular expression I can that accomplishes my goal. In this case, we have the caret, which says the start of the string, because I care about a leading pattern. And then we have a character class 0 to 9, any digit, and a plus, 1 or more times of any digit. If there were 0 or more times, there would be nothing to replace for the 0, so it would be silly to do the replace. This isn't so complicated to understand, right? And it accomplishes what we need in one line of code that is easy to understand. Regular expressions don't always even get that easy, and we'll get to that in a moment. Okay, remove a trailing pattern. That's something else we commonly do. We want to remove something from the end of the line. In this case, we're going to remove periods from the end of the line. There's extraneous periods, or we're trying to create sentence fragments or make it look fun or whatever. So even though we're removing from the end, we're using replace first because our method choices are replace first or replace all. But we're using a different regular expression this time. We have the $sign at the end, which means match at the end of the line. Then we have a dot for the period we want to get rid of. And then we have a backslash because we don't want to use the meaning of a dot in a regular expression, which is any character. We actually want a dot. Then we have another regular expression because Java is fun and we like to escape things. Okay. Next up, we have an example with string concatenation. This one is here because it's more controversial. So way back when, a long time ago, we have a question.
Can you zoom?
I can't because these are screenshots.
Oh, okay.
So come closer, there's seats in the front.
Come on, Oaks.
I will take that as a note for when I do this in February that I need to figure out how to have less on the screen or make the screenshot bigger, but for today, this is what you're getting. Okay, so what we have on the screen that's apparently unreadable is two examples of string concatenation, one with append and one with plus equals. Way back when, for those of us who were doing Java a long time, we were told you should always use append and a string builder or a string buffer if we've been doing this for a really long time in order to make sure that your string concatenation was efficient so it wouldn't create lots and lots of intermediate objects and give memory and the garbage collector and all of that stuff, and we all got used to doing it. That hasn't been true in a while. The compiler is smart enough to do what you want so that both of these amount to the same bytecode. However, we often write the more complicated one because we're used to doing so. And it's not wrong and it's not terrible. It's still common enough of an idiom that people are doing it. But it is important to notice that idioms change over time. And a new Java developer who just learned Java yesterday is going to be like, what is with you people on this append? You don't need to write append. What's also interesting about this example, though, is that various static analysis tools haven't gotten the memo that the bottom one is fine. Sonar tells you that using append is important. IntelliJ tells you about it sometimes, which I find fascinating. Depending on what settings you have enabled when you created your workspace, sometimes append is the root of all evil. And in other cases, sometimes when you use append, it lets you know you shouldn't use append anymore because Java has changed. That's fun. I discovered this one because my work machine tells me that append is fine and my home machine tells me append is the root of all evil. You can see which one has had IntelliJ installed longer. Okay, now we get up to a complicated regular expression. We have a contrived example that is a CSV with 3 fields. We are not allowed to use a CSV parser or split because this is a contrived example to show regular expressions. You should totally use one of those 2 in your real code. We also have a rule that there are no commas in any of our values because, again, contrived example, you should be using a CSV parser if you're doing CSV parsing. Imagine that. But it does illustrate the concept of regular expressions, so we're going to do it anyway. This is an example that makes me cringe of removing the middle column from the CSV. It makes me cringe because index of and substring are everywhere. Which means you have to look at this and figure out if it's right. I know it's right because I ran it. I can't tell if it's correct from code review because I have to spend so much time thinking of where array indexes are and whether they're off by 1 errors that my brain shuts down and tells me don't do that and doesn't let me complete the exercise of checking if it's right. But this is fairly common code, especially with people who learned other languages or learned Java a long time ago when there were less APIs available to us. I see we got a taker on the moving up thing, thank you. So this does work, but it's really hard to maintain and figure out what it's doing. So there's got to be a better way. And there is. It's split or CSV parser. But we don't have those options available to us. What we do have is RegX. This is not a RegX that I recommend. This is a RegX that people will give you as an example of why RegX suck. If you look at it, I agree. I mean, it's long and it's complicated and there's a lot of weird symbols in it and this works, but it's not any more readable than the string, substring, and index of example. In fact, I think it's worse because here now you have to have specialized knowledge to understand whether it works. So don't do this. This is the same regular expression, but it's in English. I'll walk through this because this is a technique that I really like in terms of showing what a regular expression can do. I hope I'm not off camera when I do this, if so I apologize. The first thing is it matches any characters except for a comma. We've got a character class here that's anything but comma, and a star, 0 or more instances of that. That's a nice sized regular expression. Even if you're not a regular expression expert, it's short, it's possible to look up and understand what these characters do. And even if you don't, it's got a variable name. It's reasonable if you're maintaining this code to take on faith that a variable named any characters except comma matches any characters except a comma. Cool. Our next one is to capture characters without a comma, which is the same regular expression, but this time with parens around it. Again, easy to understand what's going on there. Then we have comma. I hope the comma is a comma. It should be really good not to screw that up. The reason that we have a variable called comma is so that when we build up the regular expression, it's all English. By having regular commas sprinkled throughout, you have cognitive dissonance as you're figuring out what it does because you have to keep switching back and forth. Then we finally have our scary regular expression, which says, capture the stuff without a comma, match a comma, get more stuff without a comma, another comma, and then get the rest of the stuff. We've got our 2 captures, we've got our 2 things to replace, we've got a comma in between. This is English. And this works for any regular expression that you do, whether you're validating a phone number, an address, a zip code, a country, your social security number, anything. Put it in English, you really cut down on people telling you a regular expression is scary. As long as the initial variables are something that are possible to understand, you're good. You still do get people telling you regular expressions are scary, as I've learned from experience. I've been told that this example is scary. But the reason people are telling you that it's scary is habit. If they've been telling people that regular expressions are scary for the last 10 years, they see a regular expression, their first thought is, oh, well, that's scary. But it's easy to counter with this format because, all right, I'll bite. Which part is scary? Oh, is there a part that's scary?
Yeah, the $1, $2.
The one thing that's not a variable. That's fair. It could be made a variable as well. I didn't think about doing that here because that wasn't the part about RegX. I think I saw a question somewhere over here. Paul?
No, sir.
It's not a test.
No, how do you know you're only going to get 2 commas? What happens if a string CSV comes in with 3 commas? What happens?
Oh, you mean a regular assert. I was thinking about a JUnit
Yeah,
assert.
no, just a regular assert. In other words, you've got unknown data coming in.
Yeah, you're not going to get 3
You're
commas.
expecting a
Right.
certain form.
So you're not going to get 3 commas for the same reason you're not going to have commas in your characters, and you're not going to have 1 comma because this is a contrived example. But yes, that is true. That there's no validation at all, and again, you should be using a CSV parser for this. But the problem here is that it's hard to come up with an example that is easy to understand and can't be solved in another way. I suppose I could do the phone example. I chose not to because there are a lot of international people at Dev Nexus, and by having a phone number as the example, they're all going to tell me my format for phone numbers is wrong. I so don't want to do international phone numbers. That completes our section on file I/O. And if anyone notices me writing down, I'm writing down how long each section takes. It takes longer when you present in front of real live human beings than it does when you practice in your living room.
Yeah.
File I/O. Everybody deal with file I/O on occasion?
Reading that CSV file.
Yeah, there you go, with the CSV parser.
Yeah.
I deal with file I/O constantly because I'm on a tooling team. We do a lot of stuff with reporting and reading in files. But even if you don't, you're writing a unit test, you want it to read a file from disk. It's nice to be able to get that file into memory without it being an ordeal. And a lot of us remember the old way. You got a buffer reader, and then you got a line, and you read the line, and you checked if it wasn't null, and then you fixed where you had the parentheses because you did it wrong, and eventually a string would come out of that. It's 1 line now. And this is really nice, that you can do these things in 1 line without having to use a separate open source library in order to make it happen. In Java 8, the 1 line is files.readAllBytes, path. The path is the new file. And then put it in a new string because you didn't want an array of bytes, you wanted a string. That's fair. For anyone who hasn't worked with path yet, it's been around since Java 7, and you can call file to path. So if you have a file sitting around, you're good. If you don't have a file sitting around, you can just create a path. In Java 11, it got even easier. There's a method files.readString. I plan on doing some searching and replacing when our projects are fully on Java 11. It's also pretty common to read a file into a list. We want to have each line number as a separate item in the list. That's been able to be done in a one line since Java 8. We've got files, read all lines, and again, our path object. These things are really easy to do. And I'm calling them out specifically as my favorite idioms because they are so easy to do, and yet we all code by copying and pasting from the last time we did it, from the last time we did it, from the last time we did it when we wrote it in Java 7 and didn't have these choices. But it cuts down on the boilerplate. It makes your tests easier to read, it makes your code easier to read. When reading a file is one line, then this stuff. Even if this stuff is in a method, it's still in the class, and it's distracting from what you were trying to do. Because I bet the most important business logic in your class is not the reading of the file. It's what you do with the file. And finally, we have our fourth example of reading a file, which is streams. You might have noticed that there's a section on streams coming later. I am going to hammer you over the head with streams by sprinkling it throughout the presentation. Clever, I know. So we read in all of the lines from the file on demand. We don't actually read all of the lines then. We make the statement that we want to read all of the lines. And then in our case, we're going to trim the string to get rid of the white space, get rid of any lines that happen to be nuts. This is wrong. And then we're going to count all of the, oh, no, it's called num-empty lines. It really does do this. Okay, cool. So that it filters to get rid of any lines that have stuff and leaves the things that are empty, and then it counts them all. You might notice that files lines is in a try with resources. This is something that I frequently forget, and SonarQube likes to remind me that file lines, file lists, anything that you're doing that has to do with files and streams will generate a resource leak if you don't put it in a try with resources. But it's easy to forget because you're no longer opening the file, you're requesting Java open the file for you. But despite the fact that Java is opening the file for you, it is not closing the file for you unless you tell it to. So please be nice and close the file. Now we have the opposite, because we've read our file, we need to be able to write our file. This seems like it should be reasonable. Luckily, it's easy to remember because it's the opposite. To write a file in Java 8, you have to get the byte array and write that, because Java 8 deals with byte arrays. In Java 11, it's better. You can write your string directly. You can also write from a list, one-to-one correspondence there between reading and writing. Our next example shows how to combine operations. Before anyone asks, no, this is not linear. It is an example of using APIs. So file walk goes through all of the files in a directory on your file system. It doesn't need to be in a try with resources because it's not actually opening any files. It's essentially doing ls commands to see what's available. It's going through them. It's skipping the top level. So that's the folder itself. We don't want to have anything recursive going on there. Then for each one, it's copying the file. In the method, we're creating a new path. You can see how that works. And then it's resolving the path to a parallel directory, so it has it available. And then we have the part that sucks in Java. We're copying the file, but that throws a checked exception. I can't throw a checked exception because this copy file is a method reference, or if it was a lambda, I'd have the same problem. And for each doesn't allow checked exceptions. So we have this bit of ugliness. Or what I do at work, I have an unchecked wrapper class. We have a project that has things called unchecked paths, unchecked files, and every time someone needs a method, they put it in there and add this try catch block around it so that we can call these things safely. It, at this point, hasn't been edited in over 8 months, so I think we finally got all the things that we use in this library. You know, it's not ideal, but it was nice to solve that problem once instead of constantly. Oh, yeah. Okay, next up we have collections. We all know what collections are, right? Shout some out.
List,
Set.
Okay, got the big ones there.
set.
List, set, and map. Nobody said queue, but that's okay because I'm not talking about queues. Alright, so how do you create a set? In Java 8, you create a set either the long way where you create a set and add everything to it, or in one line by creating a list and putting it in a set. In Java 9 and higher, we solved that problem by actually creating a set. The latter also has the advantage of your set being immutable, which is nice. The first line is a convenience, so we've got everything in one line. The second one has a full-fledged immutable set. I'm sure a lot of you are going to jump to from Java 8 to 11, and that's cool. When you see Java 9, think Java 11. Creating a list. Arrays as lists has been around for a really long time. So we've been able to create lists in Java for ages in one line, which is good. List.of was introduced in Java 9 as well. And it's got two advantages over arrays.asList. The first one is that it's consistent with how you create a set. You're used to that. The second one is that list.of is immutable. Arrays.asList creates a fixed size backed array. You can't add elements to your new list, but you can change elements inside of it. List.of, you can't even do that. Your list is your list. If you don't like it, create your own list. Now we've got map. Map is interesting because the replacement isn't really shorter, although it is immutable. So the long way of creating a map, create your map, put all the things you want on your map, return your map. The new way of creating a map has two options. The first one is consistent with list.of and set.of, which is map.of. It alternates keys and values. So I've got the key A, the value 1, the key B, the value 2. Don't do this. You're going to mix them up. You're going to have an odd number of things. You're going to forget what pair goes with what. Your ID is going to reformat it, and it's going to be gibberish. You can do better than that, though. You can call map.ofEntries. In map.entry, we've got our keys and our values. This is at least clearer, and it's immutable, but it's not much shorter than the original. I think I've saved a line here. So the immutability part is good. The making it a one-liner part, not so much. Next up, we need to get an element out of the list. That's something we should all be doing on a daily basis, if not more frequently. How you do that depends on whether you have an equals method implemented on the object you're trying to check. If you do, all is well with the world because you can call contains and call it a day. If it's a string or an integer or an object you wrote that has equals, this is great. Sometimes, though, your object doesn't have equals, or you don't control the objects, you can't add equals, or sometimes you want to check by different fields, so it wouldn't be appropriate to add equals, or any number of the above. We used to have to write a loop for that, but we don't anymore. We get to use streams. Yay! New in Java 8. That means we're all using them now, I'm sure. Not making eye contact as everybody says no. In order to do this in one line with streams, you start with your list and you say, I want to use a stream. And then you call the anyMatch method to see if there are any matches. That sounds a lot like contains. Then the reason this is so long is because I have to define equals in the lambda since I'm not using the traditional default equals method. In my case, I'm checking the first name. The only reason this is 2 lines is because it needed to fit on a slide, and apparently it doesn't even do that well. But this does fit on 1 line in my IDE, so I'm going to give it credit for being 1 line. Really useful pattern here. I don't have to write a loop, and I can express what's going on. If I want to be really good, I can put this definition of equals somewhere else. I can put it in a helper method. I can put it in the object. Maybe in my name object, I create a method called equals by first name, so I'm not messing with the real definition of equals, but I have it where it needs to be. And I'm expressing intent. I'm not burying it in a for loop and an if statement. So that's good. Now that we know whether we can find something in a list, how about removing it from the list? Again, if equals was implemented, yes, this is great. We can call remove and call it a day. If equals wasn't implemented, we're still good. We don't even need a stream. We just need the remove if method. The remove if method takes a lambda that tells it what it should remove. And we've got our same equals method about first name. Now that this code has appeared twice, it really needs to be in a helper method somewhere else and not hard-coded everywhere. But we've got our one-liner to remove something from the list. We don't have loops. And for removing, not having the loops is even better. Because with removing, you have the problem of, well, if you loop through the list and you remove it from the list, you've messed with the iterator of the list. So now you need to make a copy of the list. You have to do that right. Then you get to explain to the new person why we're doing all of this. I've done that. The new person isn't asking you why you're calling remove if when you're trying to remove something. It's blindingly obvious. Next up is replacing. You can do that in one line with Java 8 as well. If you wanted to have some operation happen on every element of the list, we want to double it, we want to add 1 to it, anything we want to do, we can do that in one line and not loop through the list either. Then we have maps and default values. So I've got a map here and 2 keys. I want to get their values and total them up. If they're not there, no worries, I'm just going to use 0 for that number and move on. If I want to do that without the getter default method, because I'm stubborn, I can. That involves an if statement or contains or checking if something is null. If I am comfortable with Java APIs, this is even better because I can call getter default. If the value is there, I get it. If the value is not there, I tell it to return 0, and now I can just add my numbers. I use getter default a lot. I'm trying to get a value out of a list that might not be there. I want to get a new array list if it's not there. Trying to get a value, I want this to happen. Anything I want to do, I can have happen automatically by calling get or default. Next up, we're going to add something to a map if it's not present. This is not the best code though, and you'll see that over a couple of examples. The reason it's not the best code is there's a lot about how this is happening and not a lot about what is happening. So you have to read the code in order to figure out what it does, at which point you've probably lost track of what you were trying to accomplish in the first place, because the logic of adding something to a map if it's not present is not the important part. The important part is why we're doing that. Luckily, we can do this in one line. We can just say map put if absent. It's already there, do nothing. If it's not there, add it to the map. By having it in one line, we're not breaking the flow, which means the reader of the code doesn't need to worry about the context. That's good. And then we have streams, which I've been promising you for a good while. Exciting. Our last section, then you get a break for more pizza. Basic stream. Raise your hand if you're really comfortable with streams. Raise your hand if you're a little comfortable with streams. And raise your hand if you've either never used or hate streams. Notice how I didn't ask which it was, so I'm not embarrassing anybody. All right, so the brief review of streams, and it took me a good while. I think I heard the intro to streams presentation 3-4 times before it finally clicked, and then I felt like I've known it forever, is there's 3 parts to a stream. There's the source. I'm going to move again. Sorry, I'm making your job hard here as the camera person. The source is list.stream. That's telling you where you want your stream elements to come from. It's not actually getting them though. Those are going to be available later. Then we have our intermediate operations. Those either take action on each element of the stream or transform it in some way, or make it bigger or smaller. And then we've got collect. In our case, this is the terminal operation. That turns it into something that isn't a stream so we can use it later. And it does all of the work. Doing the work is important. You can think of this as if we're in a factory. There's a dispatcher overseeing this whole thing, what's going on here. So it's like, all right, we're everybody ready, everybody knows their jobs, great, we're gonna do the work. All right, source, give me the first element of the stream, hand it to the map method is trimming it, give me the other element of the stream, we're gonna start going here. We get all the way, filter throws things out, we don't want that one, we don't want that one, we're gonna do quality control here, the map guy is putting the stamp on it, and the collect terminal operation is just sitting there putting things in the gift box. It's Christmas, here are gonna be your elements, and everything gets done. For terminal operations like collect, all of the elements are processed, which is good, easy to do. Sometimes they're not though. We'll have find any. In that case, the terminal operator has another job, which is to say we're done. So that one's no good, I don't want that one, that one's no good, I want this one. Ooh, I want that one, done, 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 stop work, we don't have anything else to do. So once you have that basic mental model of what streams are doing, it becomes easier to write code using streams because you can focus on what you're trying to accomplish and not how to do it. Looking at an example of why streams are useful, we've got a before and an after. Both of these pieces of code find the maximum value in a list, returning an optional int, so if there isn't a maximum value, it returns empty. To do this the long way, I can check if the list is empty, and if it's empty, return empty. If the list isn't empty, I can sort it. Then I can get the last element in the list, which is a fun bit of Java, because you get to deal with the size of the list and the last element of the list. Or I could have sorted it in descending order and gotten the first element of the list, but then I'd have to write a comparator. I don't know if that's any better, and since we're getting rid of this code, it doesn't really matter. And then I return an optional. Or I could say I'm going to get my source, list.stream, then I'm gonna have an intermediate value operator that turns it into an int so that I can compare things numerically, and then I'm gonna return the max. That is a lot less coding there. So for anyone who's resisting streams, it is really, really, really worth the investment of time in doing so. Next up is joining a stream. This code at least is a little more readable, except for the fact that IntelliJ is complaining about it. We're going through our list of numbers, we're getting rid of any that aren't empty, and we're concatenating them, we're putting spaces in the right parts, we're hoping we didn't mess up the condition to see if it was empty. Or we could do it with a stream. We start with our source again, list of stream. We have our intermediate operations turn our integer into a string. And I know it says object2string there, that's because that's where toString is defined. When you're using a method reference, you have to use the class that actually has the method, not all of the places that are inheriting it. And then our terminal operations say we're going to use a joining collector. A joining collector turns strings into one thing. We use space as our delimiter, and the collector has handled all of that messy logic for us. Again, this is nice. It saves us typing, it saves us stuff to read. Next up, we are going to get the first elements out of a list. This one is new in Java 9, so you might not have heard of it yet, but I use this a lot. In fact, I use an open source implementation of it in Java 8 that I'm going to substitute when we upgrade to 11 next year. Getting the first element of the list, you can do it with a loop. You go through the loop, you keep track of whether you need to add it to the list or you want to stop, and you return when you stop, and then you hope that all of this makes sense to somebody. I don't know if it does to you, but that's okay. Or you can use the take_while method. The take_while method says get elements from the stream as long as this condition is true, and then stop and return it and not think about it anymore. Since I deal with build tools a lot, this is something I deal with all the time. I want to get all of the elements until there is a passing build, or all the elements until there is a failing build, and not any others. Luckily, Groovy has had this idiom for a long time, so I get to enjoy it anyway. And then we have getting either the last elements or a specific element. Again, we have our loop. We can keep track of what's going on. It's not meant to be easy to understand. That's the point of why you need a stream. Or you can use drop while, and it accomplishes the same thing. Okay, then we have our map. Maps are being created just like you would do them by hand. It takes a way of getting the key and a way of getting the value. It's really common for the key to be your key and the value to be something else, or the key to be one element, one field of your object, and the value to be something else. It's nice to know that Java can do that for you. Gone are the days where you have to loop through things and see what you want to do in order to create your map. In conclusion, and I think I've almost caught you back up to time here, being a New Yorker and talking fast helps with that. A lot of static analysis tools are really good in terms of determining whether something is an idiom or an anti-pattern, because they tell you about what are the best ways of doing things. All of these are free. Sonar runs on a server, or in your IDE, depending on what mode you use. And it tells you, it's like, oh, you're doing something that's non-standard, or there's a better way, or there's a performance problem, or really you're doing that. PMD does the same thing. You run that in your IDE or in your automated build. Checkstyle and findbugs operate in the same space as PMD. They're all really useful in terms of writing better code and finding these idioms. At this point, we're going to do questions. It says live coding. That was more if we were running ahead of schedule. Also, I've been up since the local equivalent of 2:30 in the morning, so I don't know if live coding would work anyway. Questions? Really? No questions? Yay, question.
So the design pattern book was pretty explicit about how to like collect and gather. I don't know if anyone really follows it, but do you have thoughts on like team idioms, how you would gather those for the team or document?
Okay, so the design pattern book was meant to be generic. It also predated lambdas, so it didn't have that option of how to do things anyway. As far as team patterns, I think the first thing is agreeing on what technologies you're using as a team. For example, my team has a retrospective, what should we do differently? Let's talk about using streams, right? Can we do a couple of team lunches and get comfortable using streams? Can we agree in this project we're going to use streams so people get comfortable with them? So giving people the tools in order to write good code, and then there become enough examples in order to do stuff properly. Not really idioms, but my team recently migrated to JUnit 5. What we did is me and another guy sat down and migrated 3 projects. A lot of it was automated migration, but some were things we needed to do by hand. We picked 3 projects that were representative of the types of projects that we have. And the idea being now when someone's writing a new test of that type, they're going to use our 3 projects as a reference. So when they're copying and pasting examples, they're copying and pasting them from the way we want things to be. So I think my recommendation is get the team to agree conceptually on what you want them to do and then make it easy for them to do it. Does that answer the question?
I think so. So it's kind of just like, you wouldn't have so many idioms that it's not like, you can't really remember it. It's,
Yeah, idioms aren't a list of rules per se. Right, the list of rules in the static analysis tools do help you with finding, really this should be an idiom. But a lot of the idioms are things that people would agree to. Right, for example, my for loop from the beginning. I'm sure none of your teams have a rule that says this is how we write for loops, but if someone shows up and names their loop variable turtle, there's going to be a conversation about why we don't do that. Right, so you're having that conversation of, okay, this is what we do as a team, even if it's not written down and stated everywhere. The part where you need the communication is the new stuff, right? Everybody agrees you don't name your loop variable turtle. Not everyone agrees that you should use the collect method. They haven't had enough experience, they haven't gotten exposure to it, so you need to get to the point where you agree to those new parts of the language. We also do workshops. We do lunch and learns for our department about here are some new features of the language. I've been doing that since Java 1.4 when regular expressions came out because of my regular expression story. Like I can't deal with this happening every time a language feature comes out. Other questions? Paul?
Can you enforce idioms with something like check style?
You can for some types of idioms. Sonar, PMD, check style, and find bugs all allow you to write custom rules. PMD allows you to write them in Java or XPath rather. Sonar lets you write them in Java. I really like how Sonar 5 and higher do it in Java because they provide you with an abstract syntax tree, so it's really easy to write the rules and make them do what you want. So for many types of idioms, you can do that. The trick is not having them trigger on all the old code, right? Because we're not telling people they should get rid of all the old code. We're saying when you're writing new stuff, please do it this way. Other questions? Okay, so we're going to take a break. Paul, how long is the break?
You guys got 5-10 minutes? What do you want? 7 minutes.